that the astronauts read out.
Gravitational effect of those planets.
Hi, I'm Matt, and this is NASA Now. Have you ever wondered why some balloons rise and others fall to the ground? Well, today we're going to learn how NASA takes enormous specialized balloons to extraordinary heights. That's ahead. First, here's what's happening at NASA Now. The epic battle between birds and pigs moves to space. NASA, in cooperation with Rovio Entertainment, released a real winner with the creation of Angry Birds Space. The game came about because of a simple Twitter exchange about birds and pigs in space and has grown into an overnight hit. The game incorporates concepts of human space travel and uses physics to explore ever-increasing levels of difficulty. For more information, go to the NASA Explorer School's virtual campus and look for Angry Birds Space. Balloons have been a part of NASA research for decades. Here to tell us about the huge role balloons play in NASA's high-altitude science is Debbie Fairbrother, Chief Technologist in the Balloon Program Office at the Wallops Flight Facility in Virginia.
NASA's been using balloons for science research for over 30 years. The exploration that can be done on balloons is continuing to grow as we add the sophistication into our balloons and our pointing systems. Balloons are low cost, and traditionally we get our payloads back. So you can work on a technology development where you're testing something, getting it back, recover, refly again. The most common balloon that we use is called a zero pressure balloon. It's called a zero pressure balloon because there's zero differential pressure at the base of the balloon. Our zero pressure balloons are made out of thin polyethylene film, like a sandwich wrap material. The standard balloon that I fly is about 660 feet long when it's made. So when it's inflated, it's over 400 feet tall by 440 feet wide. Think of a dome stadium. That's how big my balloons are when they reach float. The superpressure is a technology development that is intended to give us long duration at mid-latitudes. So the superpressure balloon is designed as a constant volume system. So the change in temperature between day and night is not impacted by a change in volume, it's a change in pressure or differential pressure in the balloon. So that goes into the ideal gas law where you have one system in two states. If I have constant volume, as my temperature decreases, my differential pressure is going to decrease. We use helium as our lifting gas for our balloons. Helium is lighter than air, so the mass of the air it displaces is greater than the mass of the balloon plus the mass of the helium. How we get it to go up is we have to put extra helium in the balloon on the ground. That gives us a positive upward force for the balloon system to rise through the atmosphere. And once the balloon actually reaches the float altitude, then that extra helium we put in for the lift is vented out. Now, when I have the balloon at float altitude, one of the things that's important is temperature. A balloon is a thermal vehicle. If I have the sun go away, my gases will cool and my balloon will start to lose lift. Think about when you've had a Mylar balloon for a week or two and it's kind of looks deflated. If you actually go and get your hair dryer and heat up the gas inside, it's going to reinflate. That's because you've got a constant volume and you're increasing the temperature, it's going to expand. Our 40 million cubic foot volume balloon can lift up to 6,000 pounds. That's like 1.5 Ford Explorers. Imagine picking up Mom's SUV and launching it into the stratosphere. The balloon travels with the wind, so Mother Nature's in charge. Really depends on where we're flying from and our safety constrictions on how far it'll go. When I fly in the United States, I fly from, say, Fort Sumner, New Mexico, and I'll fly to the west into Arizona. Now, if I go down to Antarctica, where there's very low population densities, the balloon will actually spiral around the pole and come back around. So that, depending on the latitude we're flying at, can be up to 5,000 miles. So now hopefully you won't think of a balloon just as a party favor, and it actually can be a really cool vehicle for science research.
Now that you know more about the science behind balloons, see how much lift a regular balloon can generate.
Teachers, your students can think and act like teams of scientists and engineers as they follow the 8 steps of the engineering design process to create a helium balloon system. Look for Engineering Design, Forces in Motion, Balloon Aerodynamics Challenge. You'll find it on the NASA Explorer School's virtual campus.
Well, that's it for NASA Now. Be sure to visit our Facebook page and leave a comment. We'll see you next time on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.